With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? A block of material of specific gravity 0.4 is held submerged at a depth of 1 meter in a vessel filled with water. Now this vessel is accelerated upward with an acceleration g by 5, and if the block is released at t equals to 0, we need to find, and we need to neglect the viscous effect. So we need to find what is the time at which it would be reaching the water surface. Okay, so let's say this is one of the vessel. Okay, now there is a block here. Okay, now the depth is given as to be here, that this is the block, and the depth is given as to be 1 meter. Okay, now this vessel is accelerated in the upward direction with an acceleration g by 5. Okay, so there would be a pseudo force which would be acting on this block in the opposite direction, that means in this direction, which would be equals to g by 5. So what would be the total or the net acceleration? We say that g net would be equals to, so already there was acceleration due to gravity g which was acting in the downward direction. Now there would be a pseudo force g by 5 which would be acting, so we say that it would be equals to g plus g by 5, so that means 6g by 5. Okay, now let us draw the free body diagram of this portion. So let us draw the free body diagram of our block. So what are the various forces which would be acting? Okay, so there would be a weight which would be acting downward, and there would be a bind force which would be acting upward. So it would be pushing it to the upward, and it would be reaching. Why? Because the density here is given as to be just specific gravity is 0.4. Okay, so it would be reaching. So this is the bind force FB, and this is the weight. Okay, so what would be the acceleration in the upward direction? Net acceleration in the upward direction. So we say that acceleration would be equals to F net, net force divided by the mass. Okay, now what is the net force? It is the buoyant force minus the weight divided by mass. So what is the value of the buoyant force? So buoyant force is density of this liquid in which it is kept, which is water, into V into G effective, or we say that G net minus what is the weight? Weight we can say that M into G, mass we can write rho into V. So it would be rho into V into G, but here G would be the effective. So it would be rho of the body. So this is the rho of the body into volume, because the total volume is submerged. Okay, and G net divided by the same factor, because we need to divide it by mass. So it would be rho B into V into G net. So what are the terms which would be cancelling? So here we can take V would be cancelled from the numerator and the denominator. Okay, so what we are just getting, so here it is just mass. So in mass it is not, gravity would not come, because in the mass, so we have just written mass. Okay, in the mass gravity would not be coming, it would be just rho into V. Now what would be cancelling? So we can just cancel this V from numerator and denominator. So what we are left with? We are just left with rho W by rho B minus 1 into G net. Now we know that our this specific gravity is given as to be 0.4. So we can say that rho, this is rho water divided by what would be the density of the body? It would be 0.4 times rho of water, because specific gravity is 0.4, minus 1 into G net is what? It is equals to 6g by 5. So from here we can see that our acceleration would turn out to be, it would be 1 by 0.4 minus 1. So it would be 0.6 by 4. 0.6 divided by 0.4 into G, 6 into G divided by 5. So this would turn out to be 18 meter per second square. Now this is the acceleration with which it would be moving upward, and it need to cover a distance of 1 meter. So we can just apply our equation of motion. So we say that H would be equals to ut plus half at square. So initially it would be at rest, so we can just put this to be equals to 0. Then our t would be equals to 2h divided by a in the square root. Now if we put the value, so it is 2 multiplied by 1 divided by 18. So it would be 1 divided by 9 in the square root. So it would be 1 by 3, or we can say that 0.33 seconds. So which option would be the correct option? 0.33 seconds. So the correct option would be the B option. So hope you have understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.